sometimes it's useful for a computer to be able to remember things, and you want it to be able to store the data of calculations that it had done previously. This is necessary for things like recursions, and so I'm going to be going over some of the simple ways that you can accomplish storing data. So one of the most simplest ways, like entry-level ways of storing data, is an SR latch. And so if you look at what it looks like in the schematics, this is what it looks like. And so you can see it has two inputs, input A and input B, and it gives out the output A, and then it has the inverse of the output A. So if output A is outputting a 1, this is going to output a 0. If this one's outputting a 0, this one's going to output a 1. So it's always going to be opposite. And so the reason why it's called SR is because it stands for set reset. So input A is a set and input B is a reset. So that's going to make sense in a couple seconds here. So if we go over a NOR gate, it is no inputs gives an output, and then one or two inputs give no output. So it basically inverses with any inputs. So if you think about it here, input A and input B are set to 0 because we're not pressing them, which means that the first input is off and this one is off, and that means that this NOR gate will give an output of 1 since it has no inputs, and an output of 1 will go out here and will turn on output A, and then it's going to go through here, come back through here, and feed into the input of this second NOR gate right here. So the output of this NOR gate is going into the input of this NOR gate over here. So that means that since input B is set to 0, and this line over here is set to 1, because remember, if both of these are off, then this means that this is on. And if this is on, then it's going to go over here and into here. So now this is on and this is off. And what that means is that this NOR gate is now going to be outputting a 0 because we have one input that's on and one input that's off, which is going to output a 0. So it's going to come out through here and it's going to trigger 0. So this is going to be a 0 over here and 1 over here. So basically, they're always going to be opposite from each other. And if we hit the input A over here and click the input A, it's going to send an input through here, which will turn off this NOR gate over here. And when that turns off, then this output over here that used to feed into here is going to turn off. And if this output has just turned off, then this NOR gate no longer needs to be off anymore. It's going to be no longer needs to be off anymore because now it has no inputs that are on, and this thing can turn on, which means that when you press this input of A over here, it'll flip the latch, and this output over here will turn on. So now that input B over here, now that this NOR gate is giving an output, if we hit input B over here, now it's going to it's going to turn off the NOR gate, which is going to turn off the signal, which is going to turn off this NOR gate, which is going to turn on the output. So it's going to keep flipping over and over again. So that may sound a bit confusing, but I have the actual built thing over here. So if you look at our little example over here, we have input A over here and input B. So if you look at our example, we have output A and output B, input A and input B, and we can think of it as input A is on, which is input A over here. It's outputting a light over here because we're not pressing input A. There's nothing going into input A, so this is off, and this is off because and this is off. So this NOR gate is going to be outputting a 1, and this 1 is going to go straight into the lamp and it's going to turn it on. So when you press input B over here, which is this button over here, it's going to send a signal to this NOR gate, which is going to turn this NOR gate off. And if this NOR gate turns off, then, or if this NOR gate turns on, it's going to send out an output through here, and the output's going to go this way and into the NOR gate, and it's going to turn on the NOR gate, which will give no output, and output A will turn off. And if output A turns off, then the signal will turn off over here, and this signal will come over here and turn off, and input A will turn off, and this one will turn off, which will turn on the NOR gate over here. So that'll output A on. So let's try that out here. So when you press this button right here, it's going to flip, and then this button over here, it's going to flip, 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 flip. So it looks simple at first. It's just like changing changing which lamp is on when you press each button. But you think of it really powerful because if we look at this lamp over here, say we want to store a number, we could say we want to store a single bit of information, right? Which is with this lamp over here, and just ignore this lamp over here. So if we want to set a single bit, say we want to set this bit as 1, right? So we click on the bit, and now the bit is activated, and we just stored a number 1 in our database, right? And then now later we want to clear our database, right? So you'd have like a ton of these things with a ton of these output A lamps, and so maybe you had this light on, and maybe one around here that was off, another one on, off, 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 off. And then you want to reset all of them at the same time. You could just click this button, and they would all flip this way and reset this thing back so you can store another data.